So in order to help you out with chapter 4, I'm going to take you back to college algebra, and I'm going to do a quick reminder of how you used to graph something like y equals 2 times x minus 3, the quantity squared plus 1. And it goes back to the generic form of y equals a, x minus h squared plus k. And that's the format we're going to use. And when we identify parts of an equation, we do take a look at the inside out order. Because if I put a value in for x, the first thing that would get affected is the h, then the a, and the k. And the way to remember that is HAK, which is hack, or better yet for us, hack, kind of, except there's a, the spelling's a little bit off. So when we get ready to graph this, y equals 2x minus 3 squared plus 1, we start to identify the parts. What's the h? The h is the horizontal shift, so it says go to the right 3. The a is the amplitude, so it gets multiplied by 2. And the vertical shift is the 1, which means it would get shifted up 1. So just going back to college algebra, when I graph this, I'm going to need 4 graphs. And if I take a look at what we have here, I always start with the parent graph, y equals x squared. Then I apply the h. Again, we're going to use that HAK, that hack sound. And it says move the whole parent graph to the right 3. Then I take a look at the a, which was the amplitude in the front. And when we multiply it by a number bigger than 1, it actually gets skinnier. And it's not so obvious here, but compared from this graph to this graph, you would see that it is in fact skinnier. And then finally, the k is the plus 1. I would shift the whole graph up 1. So now let's take a look at that same idea. We're going to jump over to Trig and see what we have going for our trig. This time we start with y equals a again. We have our function, we have the h, and we have the k, but we also have something else in there, which is the b. And the b is what I'm going to use to determine my period. Okay, so if I take a look working inside out again, I get HBAK. This time the b's in the middle, so now we have h back and not just hack. It's not going to be as nice. So if I take a look at an equation like y equals 2 times sine of 2x plus 1, you'll notice that my b is not pulled out. So for this one, I have to factor a 2 out, and I get a new equation that looks like y equals 2 times the sine of 2 times x plus 1/2 minus 3. If I identify the parts, h is negative 1/2, which means I'm going to have a horizontal shift to the left. The b is 2. So since my period for sine is 2 pi divided by 2 becomes just pi. A is my amplitude, so it's going to get multiplied by pi. It's going to grow faster. It's going to get skinnier kind of thing. And finally, I have the k equals negative 3. This graph will get shifted down 3. So we have 3 parts just the same as you did in college algebra. We're just adding that new part. So let's start and take a look at a simple one. Y equals the sine of x minus pi. And again, I rewrite it underneath my equation, and I see a is just going to be 1. The b is just 1. The k out here is 0. But what I do have is an h of pi, which means this is going to get moved to the right pi. And if you take a look at the graph below, y equals the sine of x, which is the parent function, the one I start with, and beside it you see the y equals the sine of x minus pi, and everything gets moved to the right pi. Let's take a look at another example. Y equals the cosine of 2x. So again, I rewrite it over here with that generic equation, y equals a cosine of b times x minus h plus k. The only thing that's really being affected here is a b. So my a is 1, my b is 2, my h is going to be 0, and my k is going to be 0. If b is 2, you notice the period, 2 pi gets divided by that b. My period now becomes just pi. So if I take a look at the graph, I look at the parent graph first, y equals the cosine of x, and now I know the period's going to be shortened up to pi. So instead of going from 0 to 2 pi, I now go from 0 to pi to complete one cycle of my graph. Third example here, sine y equals 2 times the sine of x. Again, I rewrite it over here. I see this time I have an a of 2, and my other values stay there. So my amplitude is 2. I look at my parent graph, y equals the sine of x, and now I want to make sure, I'm putting 1 and -1 because there weren't any vertical labels. So that even though this looks exactly the same, instead of drawing a graph that would go way up and way down, and this still being 1 and that being 2, I shortened it up to make it look like so. So again, I only needed 2 graphs, one for the parent and then one to show how the amplitude was affected. All right, so that's a bunch of little pieces. Let's put a big one together. Here I have y equals 3 minus 2 cosine of 3x. I write my generic equation, y equals a cosine of b times x minus h plus k. Could even put another parentheses in there because I see one's missing. And now I take a look. Da-da, da-da, da-da. I factor out the 3, but this just becomes x minus 0. So that's why my h is 0. My b is 3, my a is -2, and my k is 3. As a result, the period for cosine is normally 2 pi. When I divide it by 3, I get a period of 2 pi over 3. I know my amplitude now has a negative in front of it, so it's going to be flipped as well as made skinny. And finally, I'm going to move the whole thing up 3. So when I'm getting ready to do this, I'm going to ask you on the test to do this region several times, and then actually do this region and then graph a couple of them. But let's take a look. Here's the first one. Here is my parent function, y equals a cosine of x. Next thing is in order h, b, a, k. I don't have an h, so I skip it. Now I take care of the b, and that's the graph of y equals cosine of 3x. So instead of my period going all the way out to 2 pi, my period now ends at 2 pi over 3. So the period shrank it vertically, or excuse me, horizontally. After the b is my a, so I add my a into the equation. Over here, it went from -1 to 1. Again, I didn't have room to go up and down the graph, so I just labeled this as 2 and -2. And I want you to always be labeling. But you notice also the graph flipped. And then finally, the whole thing would get moved up 3. So what was down here at -2 gets moved up a whole 3. And really, my graph would keep going up over. And, I didn't have very good ones to make. But that should help give you an idea of what I'm expecting for graphing of these trig functions and what I'll be asking you to do on the test. As I said, I'll be asking you to find HBAK for several problems, and then I'll have several problems where you're going to have to show these actual translations. If you have any questions, give me a yell. Thanks.